All right, welcome to our lesson over day 5.3. We are talking about trig ratios. Day 5.3, trig, which is an abbreviation, ratios. All right, we're going to talk about what trigonometry is here first. Okay, trig is short for trigonometry, or trigonometric in this case. So basically, trigonometry is just the study of triangle measurements. Okay? And so before we even get into the rest of this, if you've looked ahead at this at all or you're staring at it right now as we're taking notes, it seems a little wordy, a little confusing. We're going to get into that in just a minute, but first I want to show you this. Okay, if we were to take two right triangles, and I'm going to tell you these are similar triangles to each other. Back when we did our unit of similar figures and similar triangles, the ratio of 2 to 4 is the same as the ratio of 3 to 6, which is also the same as the ratio of 3.6 to 7.2. This red triangle is just twice as big as this blue triangle. And I'm going to use that to help you understand that if these triangles are similar, corresponding angles are congruent, okay? And so I'm going to even mark those here for you. This angle would have to be congruent there. The 90 degrees are obviously congruent. And then these other angles down here are congruent. And so we have congruent angles. What that means is these triangles are exactly the same shape. And that's going to be important for what we're going to be talking about now. When we talk about trigonometry, the first thing we learn about are what we call the trigonometric ratios. Trig ratios are ratios of any one single triangle that compares sides, okay? And so as we look at this, it's really important that we understand kind of what we're talking about, and so I'm going to give you a little demonstration here. All right, what I want you to do, and you're going to have to pause the video to be able to do this, for this blue triangle, I want you to find three ratios for me. I want you to find A over C. I want you to find B over C. And I want you to find A over B. I want you to write those as fractions. So pause the video, write those down. All right, if you need more time, pause the video, but these are the answers you should have for these three ratios. Okay, when we compare side A over side C, that's 2 over 3.6. When I compare side B over side C, that's 3 over 3.6. And when I compare sides A and B, that's 2 over 3. Now these are different from each other. They are not going to be the same because I'm not talking about the similarity of the two triangles. But I do want you to notice what these are. And I'm going to do a little math for you here. I'm going to write the decimal value of each of these fractions. Remember when I say the word ratio? Okay, ratio means fractional value, or fraction, or comparison of numbers with division. So whenever I divide those out, they have a corresponding decimal value. And these are the decimals you get for each of these. Okay, 2 divided by 3.6 is the repeating decimal, 0.5 repeating. 3 divided by 3.6 is 0.83 repeating. The 3 repeats after the 8 there. And then this one is 0.6 repeating. And so what I want us to do now, we're going to look at the red triangle, and I've already told you that these are basically the same shape, but I've changed the side lengths. What I want you to do is come up with those same three ratios for the red triangle. A over C, B over C, and A over B. So pause the video, give yourself time to find those. And these are the fractional ratios you get when we do that. A over C is 4 over 7.2, B over C is 6 over 7.2, and A over B is 4 over 6. But when I plug those into the calculator and do that division to write a decimal counterpart, we discover that 4 over 7.2 is also 0.5 repeating. 6 over 7.2 is 0.83 repeating. And 4 over 6 is also 0.6 repeating. And so what I notice is that when I change the size of these triangles, the ratios of these sides stay the same because we're fixed in this shape. And what that allows me to do then is to come up with these ratios that are always going to be the same if I have a fixed angle measure here, meaning an angle, I'm not changing the angle into something else, okay, or this angle, or the right angle even, because no matter what size of triangle I use, if I deal with side lengths that work out in this same proportion, these ratios are always going to remain the same. And so that leads me into the rest of this lesson. So now we're going to talk about three specific trigonometric ratios, and they have these three special names. And you've probably seen on a calculator these three buttons, SIN, COS, and TAN. And they stand for sine, cosine, and tangent. And that's how we pronounce these words. Even though you write it just SIN, we call it sine, and then cosine, and then tangent. So please don't get used to saying sin, cos, and tan. We don't want to do that. We want to call them by their full name, even though we write them in short versions. So what we're going to do is we're going to look at any given right triangle where one leg is A, the other leg is B, and the hypotenuse is C. If I set that up, we have these three specific ratios that always compare the same pairs of sides. And there are other ratios I could come up with, but these are the three we're going to use to help solve our problems. Okay, the sine ratio. Okay, this is I believe that most of these words come from ancient Latin. Don't worry about that. This is the sine ratio, and it compares the leg that is opposite from whatever angle we're referring to the hypotenuse. Now, when I talk about opposite and then down here as adjacent, these refer to a specific angle as a reference angle, and the angles we use are only the acute angles. Okay, so underline that one. We're never going to talk about sine, cosine, and tangent of a right angle. We're always going to use either the acute angle, in this case A, or the other acute angle B. Okay? You have to understand that we are just using that as our reference angle. Okay, so these ratios are fractions, but they use terminology, opposite and adjacent, from one particular acute angle. So in this case, the ratio of sine angle A, or the sine ratio for angle A, uses angle A as a reference, okay? So I'm going to use my angle A. The leg that is opposite of that angle would be side lowercase a, over, meaning ratio of that one to the hypotenuse, so over the hypotenuse, C. C is always the hypotenuse. But if I change my reference angle, or change this angle to angle B, this side is no longer opposite angle B. This side is right next to angle B. The side that is opposite angle B is this side lowercase b. So that would be lowercase b over the hypotenuse C. So the angle that you're referencing changes your ratio. Then we have also this ratio called the cosine ratio. Well, sine uses opposite, cosine uses the word adjacent, which means next to. Okay? Adjacent means next to. So once again, we're going to go back and use our angle A as our reference angle, but the leg that is next to angle A, there are two sides that are next to angle A, but only one of them is a leg. That would be this lowercase b. And then the hypotenuse is still C. But the cosine ratio of angle B, we already said this earlier, that the leg next to angle B is this lowercase a over hypotenuse C. The last trig ratio we have to talk about is called the tangent ratio. The tangent ratio compares opposite and adjacent. There is no hypotenuse used in the tangent ratio. So we're just using the legs A and B. Now for our reference angle A, the leg opposite angle A was side A, and the leg adjacent to angle A was B. So it's using the top parts of sine and cosine. But if I change my reference angle to angle B, opposite and adjacent trade places. The leg opposite angle B is lowercase b. The leg adjacent angle B is A. So the tangent of one acute angle is always the reciprocal of the tangent of the other acute angle. Now, this is a lot to remember, but we do have an acronym we're going to use to remember this. And that is a made-up word, okay? representing this relationship. And that made-up word is the word so, H is silent, ka, H is silent, toa, so, ka, toa. Here's all that means. The sine ratio is always the opposite leg over the hypotenuse. The cosine ratio is always the adjacent leg, I'm abbreviating, ADJ period, leg over that hypotenuse. And the tangent ratio is always the opposite leg over the adjacent leg. O for opposite, H for hypotenuse. A for adjacent, H for hypotenuse. O for opposite, A for adjacent. And this is going to help you be able to set these kinds of problems up. And so what we're going to do now, we're going to just go through some examples that help you understand this, and we'll do maybe some more examples in class. But we're just going to use these ratios to identify fractions. Okay, when I give you the sides of a triangle and I ask for these different ratios, I'm asking you to give me fractions. Okay, so when it says give each trigonometric ratio, I want a fraction. Now we do want to make sure we always simplify if we can. So let's take a look at our first example. In our first example, I've given you all three sides. You must identify what the hypotenuse is. Okay? This side length of 13, the longest of the three sides, has to be the hypotenuse. But the other two, opposite and adjacent, depend on which angle we're using. So notice that in this first three column, we're always using angle A, but in the other three, we're using angle C. So it might not be A and B always, it might be C. In this case, B is the right angle, C is this other acute angle. So first we're going to use reference angle A to determine opposite and adjacent. If this is my reference angle, the opposite leg of angle A is 5. The adjacent leg of angle A is 12. So I'm going to label those. So to go through and do this now, sine is always the opposite leg over the hypotenuse. Well, the opposite leg from angle A was 5. The hypotenuse is 13. Cosine of angle A is the adjacent leg, which in this case is 12, over the hypotenuse of 13. And tangent is the opposite leg over the adjacent leg. So what I want you to do is now use point C as your reference angle. And that's going to change opposite and adjacent. Hypotenuse does not change. Okay, so this is now adjacent, and this is now opposite. So now these are going to kind of trade places. If you need to pause the video to give yourself time to do that, go ahead. Otherwise, these are the answers you should get. The sine ratio of angle C is the new opposite 12 over hypotenuse 13, and the cosine ratio of angle C is the new adjacent 5 over hypotenuse 13, and the tangent of angle C is the reciprocal of the tangent of A. We've flipped places, 12 over 5. Okay? Now, there's really only one other kind of example I want to take time to show you right now in the video, and that is one like example 2. This is the same thing we just did in example 1, but this time it looks like we don't have enough information. WX would be the hypotenuse, and I don't have a given hypotenuse, and so to go through with just the material from this lesson, it looks like I don't have enough information. However, if I give you two sides of a triangle, we can always find the third side of the triangle using Pythagorean theorem. So before I do any of this, I have to find the value of C. Now, the legs are 9 and 12. Those are A and B. I already have enough information to use all of those, but I need the hypotenuse to be able to find sine and cosine. So we're going to plug in 9 for A and 12 for B and find C. Okay, remembering what we did back on day 1, 9 squared is 81, 12 squared is 144. And when I add those together, I get 225. And then taking the square root of both sides, we get that the hypotenuse is 15. Exactly. Now I have enough information to write these, but I want you to watch what happens. When I do my sine ratio of angle W, making that my reference point, the opposite leg of angle W is 12 over the hypotenuse 15. I want you to recognize that this fraction can be reduced. These can both be divided by 3. When I divide those by 3, I get 4 over 5. That is the answer I want, not 12 over 15. You want to make sure you always reduce your fractions. So I want you to take some time, pause the video, and find the rest of these, but make sure you use reduced fractions. Okay, if you need more time, again, pause the video, but I did want to show you what you should have here, and then we will do the rest of these examples in class. So these are the rest of the answers you should have for number 2. Okay, the cosine ratio of angle W is 3 over 5. The tangent ratio of angle W is 4 over 3, opposite over adjacent. And 12 over 9 reduces to 4/3. Okay, the sine, cosine, and tangent ratios for angle X change opposite and adjacent. So now the sine ratio of angle X is 3 over 5, and cosine is 4 over 5. And the tangent ratio is 3 over 4. All right, we'll do some more practice with this in class, but this gives you an introduction to using trigonometric ratios.